Hi, I'm Dr. Eugene O'Loughlin, and welcome to this problem solving techniques lesson. In this lesson, we're going to take a look at value analysis. So, our objectives are as follows. At the end of this lesson, you should be able to, first of all, define what is meant by value analysis. And we want you to know when you should do a value analysis as well. Value analysis is about a lot of things. And first of all, we want you to identify components of a system or a process or a product, identify the functions of those components, and then we prioritize the functions with the highest costs so that we can target these for improvement. We're in section 2 of our problem solving techniques program, and section 2 is about identifying improvement priorities. And within this section, we've got 3 lessons, and the second of these is value analysis. So let's take a look at our quote for this lesson. This one comes from Roy Disney, who was a senior executive for the Walt Disney Company, and he once said, "It's not hard to make decisions when you know what your values are." So he placed a fair bit of emphasis on value, and that's what we are going to do here. So let's take a look, first of all, and ask ourselves, what is value analysis? Well, value analysis analyzes the functionality of a product. So this is really, really important. It's the essence of what value analysis is all about, and that's what we'll be concentrating on in this lesson. We also state an estimated cost for each function because we're going to look at value overall, and we're going to also demonstrate a function compared to that of a competitor's, so there's a little bit of benchmarking to be done here. Well, value analysis forces us to look at a product assessment for things like manufacturing processes, parts and materials, and design features. So value is really, really important, and let's see why. Formal definition of value analysis, this one I've chosen here, comes from Value Analysis Canada, and they say value analysis is a systematic and function based approach to improving the value of products, projects, or processes. So, really important words in here are function and value. So, value is something that we're all familiar with. All commercial activities are performed with the objective of providing value of some kind. And so, where the value is a combination of the benefits gained from the activity and the cost of achieving these. So, we've got a cost of doing business, and hopefully, our customers then will provide us with some benefits so that we can make enough money to sustain the business. So, value then can be considered in a very, very simple formula. Value is equal to worth divided by cost. So, any value with a value of 1 or above is considered good value. This formula gives us a value of less than 1, we therefore have bad value. So there's 2 ways that you can increase value. One is we can increase the worth by charging our customers more, and that may not be possible. There could be competitors to take into account. But another way of increasing value in this formula here is to reduce the cost. So that's what we're going to focus on in this lesson. So value analysis helps us to look at increasing value by reducing cost. So how do we do a value analysis? Well, first of all, I and the Canadian Society for Value Analysis all recommend that value analysis is best done in a workshop type of environment. So we want to create a table, and when we construction of a value analysis table may reflect a different set of factors than what we might have thought when we were looking at the value of a product, process, or a system by breaking it down. Our primary concern is to determine the functions of a system that have a high cost associated with them. So, as you can imagine, if we can reduce the cost we increase the value. So, therefore, we want to target the components with the highest cost. But we also want to take competitors' superior designs to consider those in all our redesign or repurposing or improvement efforts. So, we'll be taking a look at an example in a few moments. So when do we do a value analysis? So what we want to do is we want to increase worth, perhaps by reducing costs. So we want to identify needed product improvements. We want to constantly improve. To do this, we might want to lower product costs and then prioritize product redesign activities based on cost. And we need to do a value analysis to determine the real value of each component. We may not be able to increase value by reducing costs on a particular component, but we need to know how much any component is contributing to the overall process. So the fundamental concept underlying value analysis, as I've said, is function. So ask yourself, what does an object do rather than how is an object made? So we want to focus on function. What does it do? and components may do more than one thing, as we shall see. Let's take a look at the simplest example possible. This is often used in presentations and so on to illustrate what value analysis is all about. I have an everyday simple pencil that you see here in the center of the diagram. And I have worked out that there are 5 components to this pencil. So the first one is we have graphite. Secondly, we have a metal band. Third, we have an eraser. Fourth, I have paint on the outside of the pencil. And finally, in the bottom left here, I've identified a wooden case. So my typical pencil here has 5 components. But I also want to look at each component from the function point of view. So the function of the graphite component is to make marks. The function of the metal band is to attach and hold the eraser. The function of the eraser is to remove the marks. The function of the paint is to protect the pencil and improve the appearance, for example, with colors and logos and so on. And finally, the wooden case's function is to hold the graphite. The primary function of a pencil is to make marks. So the part here is graphite is the most important one. So the primary function being to make marks implies that all the other functions are secondary to this primary function. So for example, you will have seen many pencils which don't have any paint on them, don't have any erasers, and don't have any metal bands, but we will still have graphite in them. And you know that it's essential for using a pencil to make marks, that if you break the tip of the pencil is now functionless and you'll have to sharpen it. So that's the primary function of the graphite. Let's take a look at a more elaborate example here. And the great Ralph Waldo Emerson, once it's attributed to him, once said that if you build a better mousetrap, the world would beat a path to your door. So I have a diagram of a mouse trap here, and apologies in advance to anybody who might feel a little bit squeamish about using a mousetrap as an example. But this example is taken from Walter Michalski's 2003 book, The Six Sigma Tool Navigator, The Master Guide for Teams. An excellent book if you can get your hands on it. And as with the pencil, we've identified here that there are 5 components to the mousetrap. We've got a bait pedal, we've got a locking bar, we've got a hammer, we've got a platform, and we've got a spring. So let's go and build a value analysis table to spread this information out a little bit. So here we have a table which has quite a lot of information on it, but let's work our way through it. So this is a value analysis table, and first of all I've listed on the left hand column here the 5 components that we saw in the diagram on the previous slide. And then we've worked out in our workshop what the functions of each of these components are. So I can see, for example, for the platform, it's got 4 functions: support other parts, resist overturning, hold the trap, and display manufacturer's name. I've done this for all the other components. In all here, I've got 17 functions for each of the 5 components. And the next thing I do then is I'm going to get a competitor's mousetrap, and I'm going to compare the functions of our mousetrap with that of my competitors. So for example, the platform component, support other parts, we have judged that the competitor's design is the same as ours. Resist overturning, the competitor's designing is worse than ours. So straight away I'm asking myself, do I need to prioritize or improve the resist overturning function of the platform component in my mousetrap? Not if the competitor's design is worse than ours, because we're ahead of them. Hold trap and display manufacturers' names are the same. The competitor's design is the same. And we can work our way down through here, and we can see down at the bottom that our competitor's design is actually quite better than a lot of ours. So for example, easy to set, our competitor's design is better than ours, so we're behind them, so we have a little bit of ground to make up. So if I just used the competitor's design column here to prioritize improvement, I might get a different set of factors than what I'm hopefully going to get at the end of the value analysis. So typically, if our competitor's design is better than ours, we prioritize our design for improvement, but not yet. I also want to take into account the importance to our customers. So we do a customer survey or get a customer focus group, and we ask them about the functions of each component. And we can see, for example, the platform component, support other parts, that's of low importance to our customers. But when we go down to the bait pedal and the hold bait function, we can see that that's of high importance to our customers. So we can see, based on competitors' design and importance, that hold bait here, our competitors are better than us, it's of high importance to customers, so that in itself would mean that it's a high priority for improvement because it's important to our customers, but we're not as good as our competitors, so let's improve. So you can see all the way down through the importance column that we have low, medium, and high, three possible values. It was the same in the competitor's design. We just went for three possible values, the same, better, or worse. So that's a fairly simple way of assessing competitor's design and importance, and clearly you can use other scales of 4 or 5 or 6 point scale if you want to. I'm sticking to the 3 point done by Michalski in his book. Now, a really hard part here then is associating or estimating a cost with each function. So we take the platform component, look at the support other parts function, and we can see that the cost of that, I'm using euro here, that the cost of that is 12 cent. The next one is 7 cent, and so on down in the column here. Now, what we do then is we look and we convert those into a percentage. So what's each of these function costs, what percentage of the total is that? So I can see that the first one here, support other parts, represents 6% of the total cost of the mousetrap. So that's quite a high amount, but there are other ones down along here as well. And I want to focus in on the one here in the middle, the spring component, which has just got one function. Our competitor's design is the same, so that doesn't tell us that that's a priority for improvement. It's of medium importance to our customers. Once again, doesn't tell us that that's a priority for improvement. It costs 35 cents, which represents 17.5% of the total value of the mousetrap, and that's our number one priority for improvement. So taking a look at the swing hammer function, because of its cost, we can improve the value of the mousetrap by reducing this cost. It's such a high proportion of the overall cost that if we reduce that, we will have a much more dramatic effect on increasing value than if we reduce the cost in other components. Also, let's take a look at some of the functions here with a low cost associated. So I'm going to go to number 17, the hammer component with the prevent escape function. Our competitor's design is better than ours, so that indicates to us that maybe we should look at improving here. It's of high importance to our customer. That also indicates to us that we should maybe look at that for improving. But it only costs 2 cents out of the total cost of the mousetrap, representing 1% of the total cost, and it's ranked number 17 out of 17. So that's the least valuable function in our mousetrap. So therefore, targeting resources and time and effort into reducing the cost of this function, prevent escape. Let's say I reduce the cost from 2 cents down to 1 cent. That's halving the cost there, but that would have a minimal effect on the percentage. It would reduce it from 1 to 0.5% about, and it would still be a very, very low priority. So spending time and effort on improving prevent escape is not going to increase the value of my product compared to if I targeted my 1, 2, or 3 priorities here for improvement. By tackling those and reducing the costs of one or more of those 3 high priority components or functions, I will therefore have a much more dramatic effect on increasing value by reducing cost. Now, there's a few things we should consider here before we finish off. What do we do next? Well, first of all, as always, recheck your data. Recheck your costs and percentage calculations and priorities and so on here. And because it's a spreadsheet, you can do what ifs and so on in there as well. But you have to ask yourself, what is the cost of redesigning each function? So the cost of redesigning, for example, the ones I highlighted, the 17th one, prevent escape, which is only 1% of our total cost, the cost of improving that might actually be very, very low, and therefore we might consider it. Our number one priority, which is the spring component with the swing hammer function, which represents 17.5% of our total cost and then is our number one priority, that might actually cost a huge amount of money to redesign. Maybe you have redesigned it already and reduced the cost, and it may not be possible to reduce it further. Maybe you're relying on the spring from a third-party manufacturer. Maybe you can go to a different supplier and get a cheaper spring. But that could have an effect on your comparison with your competitor's design. So there's a lot of things to consider in here. How difficult it is to redesign any product. So the low cost ones might actually be very easy to redesign, and it might be worth doing. It might reduce cost and increase value by a small amount, but nevertheless, that might be worth doing. And you need to consider something like a cost benefit analysis to help you make some of these decisions. So there's a lot of things on this table here to consider, the components and the functions of those components. We're comparing our competitor's design with ours. We're also looking at the level of importance to our customers. considering the cost of each of those functions, working out the percentages that allow us to set the priorities for improvement. Well, by the way, you see some NAs in here, but of course we're not going to be cruel here and actually kill some mice when we are comparing with our competitors. So that's why you see NA in some of these slots here. So an assignment for this section, which will follow this lesson, I'm going to ask you to look at the functions of the components of a particular process and then compare a competitor's product with your product. What is the importance of each function to your customers? We'll look at some customer data and the cost associated with each of those functions. What is the percentage cost to work that out so that we can identify then our final thing, which is what we really want to do, is our priority list for redesign. Remember to focus on the functions with the highest cost associated with them. So in summary, in this lesson here, value analysis is about looking at the functionality of a product or a system or a process. And then we work out the estimated cost for each function. We want to compare it with our competitors and also look at the importance to our customers. We identify primarily the function or functions with the highest costs. These then we prioritize for improvement. And finally then, this allows us to increase value if we can do that. So that's what value analysis is all about. I hope you found this lesson useful. Thank you for your attention.